Hello class, we're about to start section 7.2, multiplying polynomial expressions and functions. In the expression b to the n power, b is called the base and n is called the exponent. Now, we have exponential form, which you see down here with all of these exponents. And then we have repeated multiplication form and simplified form. Now, hopefully, this will not jump like the last video, but if it does, I will verbally tell you what to write. Okay, now, this 3 is taken to the 4th power, but not the negative sign. So we'll put our negative here, and then we will write repeating 3's. Should be 4 3's. Now I will tell you this, typically I will put the 4 3's in parentheses, but you can leave them outside the parentheses as long as you know that negative is out front. Simplified form is just you multiplying all this together, and it will give you negative 81. Okay, now, if you notice here, we have a negative 3, but it's in parentheses now. So we will write negative 3 in parentheses 4 times. Now, we know a negative times itself 4 times. Well, a negative times a negative times a negative times a negative, we know is positive. So our answer here would be positive 81. Now look here at 2x to the 5th power. Now with 2x to the 5th power, the only thing that's being taken to the 5th power is the x. The 2 is not. So we will write down 2 and then 5x is behind it. Because we know when they are together like this, this is considered to be multiplication. And then simplified form is still just 2x to the 5th power. Now we look here, we have 2x in parentheses to the 5th power. So we'll write 2x times itself in parentheses 5 times. So now, if we multiply this, we'll multiply all the 2's together, and that will give us 32. And all of the x's will give us x to the 5th. So our final answer here would be 32x to the 5th. Any questions? Okay, now we go down here to the center of the page. It says caution, negative a to the n and parentheses negative a to the n are not necessarily the same, which we saw in a previous table. It says how many 5's are being multiplied together in the expression 5 squared times 5 to the 6th. How many 5's you think are being multiplied? How many? 8. It's 8. It's 8 because you have, first you have 2 5's. And then you'll multiply 6 more 5's. And when you total them up, it equals 8. So now this is called a product property because both of these have the same base. So the product property states this. If you have the same base and you're multiplying, you add the exponents. So we could have added, since these had the same base, we could have added 2 plus 6. That would have given us 8. So this is the same thing as saying 5 to the 8th power. Yes?
Can you say that again if you have the same base and you're multiplying one?
If you have the same base and you're multiplying, you add the exponents. You keep the base the same, but you add the exponents. So just like up here, even though we had 5 squared and 5 to the 6th, we keep the base at 5 and we add the exponents. Okay, now we come here to A. It says use the product property for exponents. Now here, we know 3 times 7 will give us 21. Now we look here, this is x times x to the 4th. X and x are the same base, right? So now we add the exponents. Remember, this x has an exponent of 1. So we add 1 plus 4, which will give us 5. So it'll be x to the 5th. Okay, next we come to B. 4 times negative 6 is a negative 24. Now we look at our x values, our base of x. We have x to the 5th, x to the 3rd. We will add those exponents. It will give us x to the 8th. Keep the base the same, add the exponents. Yes?
Even though that that negative 6 is negative, we don't minus the exponent?
It doesn't matter.
It doesn't matter.
Right. The only time you would subtract exponents is with division or if one of your exponents is negative. Then you would add a negative number, therefore subtract. But we would get to that later. I mean, I understand math is exciting. You want to keep going on. All right, let's go to C. Okay, now we have a monomial multiplied by a monomial. We'll take 4 times negative 2 is negative 8. X to the 3rd and x squared. Same base. We'll carry over the base. Add the exponents. 3 plus 2 is 5. Now y to the 5th times y. This y is taken to the first power. Same base. Carry over the base. Add the exponents. 5 plus 1 is 6. Now we look here at D. We have 3 values here. All of them have, or 3 factors here. All of them have the same base. So we would carry over the base and add the exponents. 2 and 6 is 8 plus 3 is 11. So it'd be x to the 11. Now we go on here to the next page. Now it says add, subtract, and multiply the monomials as indicated. If it is not possible to perform the indicated operation, write cannot simplify. Okay, so now we have A. Now remember, in order to add or subtract, you must have, they must be like terms, meaning they must have the same variables and take it to the same power. So now we have 9x plus 9x. They have the same variable. The variables are taken to the same power. So you would add the coefficients and carry over the variable. Now we look here at B, multiplication. 9 times 9 is 81. X and X have the same base. Their exponent is 1. You add the exponents, it'll give you x squared. Look here at C. The variables are not the same because the exponents are not the same, right? So you will write cannot simplify. Now if you look here at D, we have multiplication. We can multiply. 2 times 8 is 16. X to the 4th and x to the 3rd has the same base. So you carry the base and add the exponent. Look down here. We have the same variable, same exponent. We subtract. 3 minus 8 is negative 5. And we carry the variable in this exponent. Now for F, 3 times negative 8 is negative 24. X squared times x squared will give us x to the 4th. Same base, add the exponent. Now we look here at G. We have 7x squared minus 7y squared. They do not have the same base. They do not have, in order to add or subtract, you must have the same variable, same exponent. They do not have the same variable, so it cannot simplify. Then we look here at H. 7 times negative 7 is negative 49. X squared times y squared will just be x squared y squared because they didn't have the same base, so you would just write them as is. Are there any questions? All right. Now we go down to the bottom of this page. Note, In order to add or subtract, there must be like terms, same variables to the same power. But when multiplying, this is not necessary, which we saw throughout these problems. Now we have example 3. Find the product of a monomial and a polynomial. Now right here, even though this looks a little different, this is just a distributive property, right? So we would take 5x times 4x plus 5x times 7. 5x times 4x will give us 20x squared, and 5x times 7 will give us a positive 35x. Now we look here at B. We have 3t squared times 4t cubed plus 3t squared times a negative 7t. 3 times 4 is 12. T squared times t cubed is t to the 5th power. Now, a positive 3 times a negative 7 will give us a minus 21. T squared times t is t cubed. And that is the final answer for that problem. Okay, now we come down here to C. Same thing, distributive property. 6x cubed times 3x squared plus 6x cubed times a negative 2x plus 6x cubed times a negative 7. So now, 6 times 3 is 18. X cubed times x squared is x to the 5th. And then 6 times negative 2 will give a negative 12. X cubed times x is x to the 4th. And then 6 times negative 7 is negative 42. And then we'll bring down our x cubed. And that is the final answer to this problem. Now we go here to D. D, we still do it the same way. I just need a little bit more room. I don't know if I have it though.
Well, since you...
So we would take negative 2xy squared times 3x squared minus 2xy squared times a negative 5xy, and then minus 2xy squared times y squared. Okay, so now negative 2 times 3 is negative 6. X times x squared is x cubed, and we'll bring down our y squared. Negative 2 times negative 5 is a positive 10. X times x is x squared. Y squared times y is y cubed. Next, negative 2, we know inside this parenthesis it'll be a 1, so that'll just be negative 2. There's no x inside of the parentheses, so we'll bring down the x. And y squared times y squared is y to the 4th. And we're done with that problem. Now, we scroll to the next page. It says multiplying two binomials is really just a matter of using the distributive law twice. But there's a memory aid that most people use. Most of you have heard of FOIL, right? That front, outer, inner, last. Now, I typically don't teach FOIL, but I'll just go over that here. You have the front values, which would be x and x. So you have x times x. The outer would be x and 5. So it would be plus x times 5. The inner would be 3 and x plus 3 and x. And the last would be 3 times 5, which would be the last two values. So you have x squared plus 5x plus 3x plus 15. Then you combine the middle two values here. You have x squared plus 8x plus 15. And that will be your final answer. Okay, so basically, we do that for, I'll just let you all copy that for a couple more seconds. We basically do this for A and B as well. So I want to write that out. So we have x times x plus x times 6 plus 4 times x plus 4 times 6. So this would be x squared plus 6x plus 4x plus 24. And we have x squared plus 10x plus 24.